Good afternoon. Thanks for joining us today. My name is Oliver Ratzesberger, and I'm going to take you on a journey of advanced analytics and the evolution of companies as we have seen it and as we are looking into the future with data-driven businesses. The story that I'm going to tell you today is about the Sentient Enterprise. And I've had the fortune to work with Mohan Sawhney of Kellogg School of Management over the last year to compile the various use cases and stories that we have seen out there of companies evolving around data and agility and advanced capabilities into a maturity model that we call the Sentient Enterprise. With that, I want to start off and let's talk about a couple trends that we are seeing in the industry that are really important to what we're doing with analytics and how companies should deal with that. This gentleman here, his name is Robert Ney. The interesting story about him is about 2 years ago, at the age of 12, he released a game on the iTunes App Store. And within the very first day, he got to 400,000 downloads on the iTunes Store. He basically pushed Angry Birds to the #2 spot. Angry Birds being a game written by a large company, of course, with a lot of engineers. And what is amazing on top of just him being able to do that in the first place is how he did it and how he went about that. And he basically took an SDK, an open source SDK from the internet, downloaded it, started developing the app. He started conceiving or starting the game in late November of that year, and he released it before December in less than 30 days. And if you think about that for a moment, that a high school kid in less than 30 days can write an app on a mobile platform is quite impressive, right? It really shows us what is happening in technology overall. Not only do computers get faster, platforms are allowing us to do things in new ways where technology is evolving at ever faster speeds and has included people now to be able to build advanced capabilities on top of highly complex platforms. If you think about that, a high schooler certainly doesn't understand a mobile platform and how gyroscopic sensors and all parts of the hardware work together. Yet the platform has allowed him to build a really interesting and advanced application, a game in this case, deploy it, make it available to hundreds of thousands, ultimately millions of users, and find an audience that is willing to accept that and download that onto this platform, right? It's a really interesting concept if you think about that, because the way we are looking at computer systems is changing. The way we're looking at technology is changing. It is very rapid iteration. It's highly agile. I hear these days quite often that people say, well, agile is no longer fast enough for us. We need to be faster than agile, right? And if you think about that, that's quite an interesting problem to solve with, especially when we in IT are not always capable of doing these things in a very agile way. So let me tell you a little bit more about that. Not only do platforms evolve faster and faster, since the beginning of the internet, we have created something like 1.8 trillion gigabytes of data. That's something like 500 quadrillion files around the world. And not only is this a very, very large number, it's doubling every 12 months, right? And so data is exploding on us. We are doing things faster than ever. Every app that we create produces more data out there, right? And these are really interesting problems. Now, if you overlay what we as consumers are really getting used to, is a couple of trends there, like real-time interaction, right? I remember when I opened my first checking account, I would get once a month a statement that would tell me how much money is in my checking account. And I would, in between, keep a log and write down every check that I've written so that I roughly would know how much money is in the account, right? Today, that's no longer acceptable. You have an app, you have a website, you open your cell phone, you look at it, and you have your information in real time. Whether that is your banking account, whether that is your flight information, whether you travel on business or vacation, everything is turning into real time, right? And we really expect real-time interaction with all the data elements that we see out there. The other trend that we're seeing in the industry is about self-service, and we're calling it self-service everything. Imagine that you want to interact, for example, with your bank, right? Going to a bank in person and seeing a person there is usually not what we do anymore, right? Even calling a call center is sometimes annoying to us. Waiting for 20 minutes on a phone line until somebody picks up and talks to us. If I can do the same thing through a web page or an app, I will prefer to do that. I don't have to explain somebody that I'm already authenticated. So self-service is becoming a big trend, right? And if you compare just those two things, real-time and self-service, those are usually not strengths of IT departments. More and more CIOs are being asked to deliver things faster in more real time through more self-service rather than through traditional methodologies and ticketing systems and fill out this requirements document and then several days later or weeks or months we'll get back to you, right? It's a really interesting time around data. And there's a couple key questions that really come up in organizations all the time. And we see a lot problems of companies dealing with data, as in we're dealing with a lot of data anarchy. There's a lot of silos of data out there. There's a lot of certain departments have their own data. They share or do not share that data with somebody else. Everybody wants to be in control of their own destiny, wants to build their own systems. It usually doesn't work very well at scale, right? Because now you have to search a lot of silos out there. We use a lot of humans to direct data around. We call it ETL, right? Extract data from somewhere, do something to it, and then load it somewhere. And it's a very slow process if you think about that, because it always involves a human being for every single column or table that we touch, right? We spend a lot of time sifting through data. We don't always know where to start looking at data, and therefore it's quite often kind of this needle in the haystack problem, right? We don't know what we don't know, therefore let's go look through data, right? And we spend very little time on decision making, a lot of time in just looking at plain data, right? And all of these problems ultimately result in a lot of fire drills in companies. We spend a lot of time putting out fires, as in departments that need to look at, oh, where did this data come from? I can't find that data. Who has that data in the organization, right? Or why does my data look different from their data? And that weighs down on organizations quite a bit. The way we as an industry have approached this problem for the longest time around data is what we call the enterprise data warehouse, or the EDW, right? And I think as an industry, the majority of us have made a mistake over the years on how we go about building these EDWs. We have taken proven software development methodologies, typical waterfall methodologies where we say, go write a requirements document, then we write a design document, and then we architect it, and we spec it, and we build it, then we test it, and then we roll it out. And quite honestly, the problem with companies is around data, that data is a big unknown factor in this game. We don't know what data will tell us. Therefore, our ideas of what we want to build with data are kind of back of the napkin ideas at first. Quite often, business executives have an idea, start out with an idea, they come to IT, they come to the CIO and say, I have this idea, I want to build something with data, right? Or I need to build something with data. We need to change how we do interactions with our customers, or increase productivity, or deal with churn or other problems. And what happens is quite interesting. The first thing that this idea meets is like the threaded requirements document, right? 50, 100 pages, here's your requirements document, go fill that out. By the time you're done, you give it to us, and now we can spec this whole thing out. What the business executive or the business team won't ever tell IT is, we really don't know what we want, right? We have an idea, we know we need to be better in this, but what data will support that? We just don't know, right? And so we put somebody that really doesn't have a detailed idea of what they want in front of a requirements document, and what happens is usually, give me all data, in all possible combinations, build me any possible dashboard with all drill downs, right? And so it gets very broad, of course, right? And when an IT person or a product manager looks at these documents and say, oh my God, this is huge, right? It's gonna take us forever to build this. They're completely unreasonable. They want all data. We can't do that, right? And so what happens quite a lot is that in organizations, any projects around data or that enterprise data warehouse start taking 18 months or longer. In fact, I've talked to a lot of business executives over the last several years that said, 18 months, are you kidding? This is best case for us. It takes us 2 to 3 years to do something significant, right? And this is a real problem, right? We just talked about real time. We just talked about self-service. Even 18 months are a showstopper. If marketing comes to you with an idea, what they want to do for this Christmas season, and you show up 12 months from now, you get likely 2 responses for them. They will either say, that is so last year, right? And I would have needed that last year, but you didn't give it to me, so therefore I made things up and I somehow got along without you. Or they take a first look at that thing and they say, well, I did not expect that, right? This data is telling me something completely different than what I was expecting. So here's 50 new questions. Build me new dashboards. Or here are the change requests, right? And so we are in this process of very anti-agile waterfall meets unknown data, means unknown details. And it's really putting a strain on a lot of companies and a lot of IT departments. And so for all the good and right reasons, what is the thing that we usually do as a company? Well, we say, we want to be agile. I'm an executive, I'm in marketing. I can't wait for IT, for the data warehouse to build me something in 18 months. I'm going to do it myself. I have a budget, I have some OpEx dollars to spend. I'm going to buy myself a little database, system, whatever it is. Technology doesn't matter in this case at all. And what do we do is, I'm just going to take the data that I need and I'm going to put it into my own database, aka data mart, right? And I'm going to be super agile. The next 30 days I have results, next 90 days I have results, right? And ultimately what happens is you get some quick wins out of this, right? There's some executives, some teams that will, within 30, 60 days, will really make some interesting insights or results and deliver them. Now, if you fast forward a couple of months, a couple of years into that journey of data marts, you will all of a sudden find the other side of that agility, and that is 2 executives meeting with the CEO, for example, and discussing what are the latest metrics. How many active customers did we have in Q2? And 2 executives will all of a sudden come up with 2 completely different numbers. And I've seen it where this is not a 1% problem, where the numbers are slightly different. I've seen where the numbers were off by more than 50%. And where executives in companies started to all of a sudden question all the data that is out there, because whoever they ask comes up with a completely different answer. And over the years, when I was at eBay, we started to realize that this is a real issue. And we said we have no metric around that. And we actually gave this problem a name, and we called it data drift. Data drift is the problem of when you copy data from one point to the next, the moment you are done copying it, it's already outdated, right? And now combine that with agility in mind, combine that with the fact that I don't want to follow process, right? I don't want to follow documentation, architecture, because that takes too long. I'm going to be agile. When I copy things in an agile way, it also means I usually don't do a very good job in error handling and in dealing with error situations. And what happens is from that day on, things will go wrong very quickly under the covers. Data will drift away. The example that I have is we had a data mart, a big CRM data mart in the early 2000s. That simply started to grow out of its own size. 10 terabyte CRM data mart that basically ran a lot of the email campaigns that we were doing every day and the interactions that we were driving with our customers. And because it outgrew its capability and it started to take longer than 24 hours to load its data, we had to take a different approach. And so we said, let's bring this back into the EDW, but let's do it in a very different way than we have ever done it before. And that's when we started creating a new concept and bringing in data in a very agile way. And we said, the first thing that we need to do is we need to time box ourselves. We need to, within 90 days, need to get this project done. And within the 90 days, if we do that, of course, that doesn't leave time for re-architecting. That doesn't leave time to optimize a lot and redo things, which is, as IT, we try and we like to do that a lot. Whenever we have an old system, what's the first thing that we want to do? We want to re-architect it because it's so bad the way it is. I could do this so much better. The danger with that is that we run into situations where 2 years later, the old system is still running. The 20 reports that everybody needs still come out of the old system, and I have the perfect new system, except it still hasn't replaced the old system, right? And the strain that that puts on an organization is like, now I have half of the people running with the old and half of the people on the new one, can't make progress in either way. And so time boxing became a really important thing for us. 90 days, get it done. And since 90 days doesn't allow you to re-architect that, we said, take the existing data model, copy everything over as it is, right? Just dedupe some of the things like customer table we already have here, email table we already have, transaction table. We don't need to have 2 copies of that, right? And we thought, well, user acceptance testing is going to be really easy because same data model, same data, same reports, just pointing against a different system. We should be done in no time, right? And then we started comparing the results, and they were like completely off. I mean, off to like 60% off. And this is where we started realizing the data drift problem. What happened was that 60% of our customers and customer records were missing in this data mart. And when we started looking underneath the cover, what we found was that when we built this data mart and when we did it for agility and when we skipped a couple of the processes, right, we built a problem for ourselves where we had nightly problems, we lost a couple records here and there, and now you run this for 3 years, all of a sudden, like the majority of records in that system is out of sync, outdated, or missing, right? And we also started realizing that measuring data drift is actually very complicated, right? Because how do you do it? You copy the data from one system to another, right? Or the other way around. Or you run really, really heavy queries that sum up and count every column and compare them with something else. You don't have time for that, especially if you do Agile, you don't do that, right? So data drift is a huge, huge problem. Not only did we realize that data drift was a problem, we started also realizing that we spent a lot of people time on these problems. We measured and did studies, and we found that up to 75% of an entire analytics organization of something like 250 people was spent on basically copying data around over and over and over and over. Not just that, but then dealing with the outcome of data drift. These are the fire drills. The CMO coming and saying, my system is showing me we had 5 million active customers. The CFO says, well, my analysts are telling me we had 7 million. What happens? Both send an email to their team and say, go find out why their data is wrong or why our data is right? And so ultimately, between the problem of data drift and the amount of people time that we spent on that, we started realizing the cost is enormous of us doing that. Again, we start out with agility, we end up with the anti-agile problem here, with wild, wild west, with data drift, and with a lot of people time spent on that. And so not only did that happen, of course, but we also realized that, we have a lot of copies of data, of course, around, right? And at first we were like, yeah, okay, we have 2-3 times the data that we actually need. When we took that particular CRM data mart, that was 10 terabytes of a system by itself, and we brought that into DW and just deduped the big data sets that we had, we were left with 500 gigabytes of new data. 10 terabyte system, 500 gigabytes new data. We're like, oh my God, this is way bigger. Because not only do we do this once, we do this all over the place. We probably have hundreds of copies or hundreds of times the storage out there. And so all of a sudden you start realizing cost per terabyte is very important, but something times 100 or a couple of hundred, you need to solve the problem at a different scale, right? You need to figure out how to reduce these copies of data, or this really gets out of control. And at AGILE we came up with a pretty provocative tagline that I've used ever since, where we said, a data mart cannot be cheap enough to justify its existence. What we meant with that was, it's not the cost of a database that I buy myself to do some analytics on it. It's everything that happens after that. It's all the people time that we tie up with the cleanup over the years in something that looks very cheap, a couple $1,000s, a couple $10,000, a couple $100,000, depending on scale, can easily cost you tens of millions of dollars in people time in an organization. Except it doesn't show up in a line item in your budget, right? You don't see it if you don't look what your people are doing. So, great. So this is actually the start into the concept of the sentient enterprise. Great. We want to be agile. We just said, okay, for agility we do data marts, and then we come out of that saying, well, but we don't like them because of their implications that we have. And so this is where the 5 stages toward the sentient enterprise really start. And I want to give you a quick step-by-step walkthrough of what these 5 stages are and what is behind that. The very first stage of the sentient enterprise, and we called it the agile data warehouse. It's a little bit of a provocative name because usually the data warehouse, the enterprise data warehouse, is seen as the anti-agile platform within most companies. This is where you wait 18 months or longer to get something done. Now, there's a lot of talk right now in the industry that, oh, with big data, we become agile. And what I'm going to show you here is that if you can't do agile with your data warehouse right, don't even try to be agile with big data. It gets a lot worse from here on out. And so getting agility right in designing an organization, designing how you deal with data with agility in mind is the absolute foundation for everything that comes after that. And so we learned over the years that this is not technology, this is culture, this is process, this is how you get people together, this is how you train people on how to do that and not just let it happen. I've talked to companies over the years that said, oh, we are agile, right? And I said, tell me how you're agile. Well, we do daily stand-up meetings. I said, okay, that's great, right? There's a lot of agile methodologies that do daily stand-ups. What else? We no longer write documentation. Okay. We no longer do architecture. It's like, okay. So basically you're telling me you're doing wild, wild west, right? In the pursuit of agility, you drop best practices. And here's the danger with that. That works great for a quick win. That works for the first 30 days, 90 days, maybe even 6 months. But after that time, the burden of this agility starts setting in. People move on that build certain things. Oh, we can no longer figure out who left that data behind, who built these scripts. Oh, there's not even version control around that, right? There's no best practices. And so it's really important to do agility the right way and not just let it happen. And so, as I said before, we realized that these EDWs and all of these data marts were really starting to drag on the organization. And we spent too much time on being non-productive or not producing new results and just dealing with the fallout of that, right? And so we sat down, it was probably around 2004, 2005, where we said, how can we create an infrastructure that gives business units self-control, that lets them build new ideas out, try them out very quickly, without them having to copy half of our data around in order to do that, right? And at first we thought like, oh, perfect use case for cloud. And back then we were just getting into cloud ourselves, right? It's like, okay, instead of buying a database, why don't we just provision a database in the cloud? It's very fast, right? I mean, I can save weeks of time doing that. And we played it through amongst our leaders, and we started to ask ourselves, so how would that work? Okay, I go to the cloud, let me provision a little database. And we said, okay, what's next? Well, the first time you look into this cloud database, what do you see? Well, usually nothing, right? It's empty, right? There's no data in there. It doesn't matter what technology that you use either. And you can stand up anything in the cloud today. But the first time you provision that thing, this thing is empty. So what's the next step that you need to do? Start copying data there. It's like, okay, timeout, right? This is exactly the problem we are trying to avoid. The database in the cloud certainly doesn't solve that. So we need a different way to look about that. And we came up with that concept that we called initially virtual data marts, where we said, you know what? We want the ability of giving somebody a self-service database, a sandbox, a data lab, as we call them nowadays, right? Where they are in control, where they can load and integrate data, but where all of the underlying data is already there. And we built a platform and a self-service interface that allowed anybody in the company that had access rights to our analytical systems to create their own sandbox. Now, the moment we started, again, talking that through, it's like, okay, great. We no longer need to copy data around. We have all the data that we're allowed to see already there. That means I only need to give out very, very small pieces of storage, because as we've heard, one of our largest data marts, once integrated in this sense, was only 500 gigabytes of data. So we started out saying, what if we give everybody 100 gigabytes, no question asked? You come to us in less than 5 minutes, you have that system provisioned, and you can start loading data, you can start storing data, you can combine it with all the data that is there, right? We also started realizing that if we just did that and nothing else, this would become a very unorganized, everybody creates their own little sandbox, everybody loads whatever they want in that, and then 12 months from now on, we would have just like huge, huge problems with that. And we said, so the moment you do self-service, the moment you do agility, it's critical to get governance right and built into a self-service model. That means the first thing we decided was, if we do virtual data marts, we're going to time box them. Back to that concept that we did before. We're going to give you 30, 60, 90 days. You pick it, as long as it's one of those three, right? We give you a time box, and after that time box, 15 days before the expiration, the system will send you an email saying, hey, your data lab is about to expire. We made it super easy to extend that, but the human being had to open the email, click on that, and say, I'm going to extend it, right? I'm still working on that. Of course, we kept track of who re-upped their data labs or their virtual data marts. And when people did that a couple of times, they were on our radar of like, okay, somebody's doing something interesting there, right? We also trained people on what to do and what not to do with that. Training is very, very important. You can't just let a very powerful infrastructure loose on untrained people. So we made it a requirement. If you wanted a data lab, you first go through an advanced training class that we offer, right? And with that, it's kind of your driver's license to your data lab, right? We also started realizing that the moment you do self-service like that, you as the service provider really need to analyze what people are doing with that. And that's a concept that a lot of companies today don't have in their tool set. And I often refer to it as analytics about analytics. It is really important to take the logs of what people are doing with their data labs and follow them along. Just as important as it is for an e-commerce company to do clickstream analysis. If you build new web pages and you don't analyze who is using them, you might build pages that nobody can find, right, on the website, or nobody is using because they don't like it, right? Or you lose people in the shopping cart because it was just too difficult to get to the next step. The same applies to analytics. When you have a sandbox, you need to analyze what people are doing with that, right? You need to do it for governance. You need to also do it in order to learn from the behaviors and help you design the next iteration, the next capabilities that you have. So virtual data marts, really important. Now, virtual data marts by themselves are just another tool. What you need to do is you need to focus very heavily on the organization. And in our case, we decided we're going to use Scrum as a methodology to be agile. And we trained technology people as well as business people to work in a Scrum-based environment, put technology and business people together into the same teams that would do daily stand-ups, that would work in the same war rooms, that would have tools like virtual data marts and upload tools available, where Monday morning an idea, by Monday afternoon I have some results. By Wednesday, I might know if I'm onto something or not, right? Doesn't work for everything. We also learned that agility only works for certain use cases. And there's other use cases where you don't want to be agile. If it's something like upgrading a data center, you don't do that agile. You plan for it very, very heavily, right? Just like you build an airplane with a lot of planning, and just like you build a power plant like that. There are certain things that don't work agile, but there are certain things, especially around discovery of data, where you don't know the outcome, where you don't know if it's even feasible, where agile makes a lot of sense and helps you cut down really on that time. And virtual data marts became a foundational piece of that. We also built another concept, and this is a totally logical concept here. Call it a layered data architecture. Has nothing to do with systems, has nothing to do whether you have one system or a dozen systems, what technologies that you have. We try to break down the meaning of data into very, very simple terms here. Think of this as big animal pictures. Think of this as, how can I decouple the different things that I do with data? And if I decouple that, how can I leverage that in Agile? And so if you take a look at that layered data architecture, I'm going to explain to you a little bit what the different layers are and what the meaning is of that. So layer 0, the very bottom layer of the layered data architecture, is meant to be the raw layer. It is where data arrives in its native form. Think of it as the layer where you do ETL without the T. Yes, you extract from somewhere, yes, you load into it. The goal for that layer is preserve lineage, preserve structure, but deal with the fact that it might change over time, deal with the fact that you don't know how to data model that, and you should not. The layer 0 should not need a data model other than the data model that you inherit from wherever you get the data. And the big difference in this, in some of the where the industry is today with big data is, there's one big difference, as in, I said, preserve structure. If data is transactional, if data comes out of an existing system, an existing database, don't throw away the structure and unstructure it and write it into text files so that everybody else who now wants to use it needs to restructure it and reapply structure to that. But build an environment where structure, semi-structure, and no structure can reside next to each other, right? And let's take a look at the next layer on top of that. We call it the integration layer. Traditionally, we would have looked at this as this is where you do the data model. This is where you build an enterprise data model, right? And again, together with the EDW, we have gotten to enterprise data models that have 20, 30, 50,000 tables. We have data modeling teams of 5 people that should maintain a 30,000 table data model. Not really good. And if you look, if you do this analytics about analytics, and if you look who is using what portions, sometimes less than 2% of these data models are actively being used over and over and over and over, right? So we spend a lot of time up front in modeling, and then we only use a part of that. And we started realizing data integration is a spectrum. It goes all the way from highly typed, highly modeled pieces of your data to less and less and less modeled pieces. And in certain pieces, it's okay to keep the original structures as is. That's good enough for a first use case. Layer 2 on top of that, calculation layer, very simple. Any sort of calculations, KPIs that you develop, you want to put that into a layered data architecture. Why? Again, we learned from our own mistakes. We used our BI tools and their metadata capabilities to calculate revenue and margins and churn rates and whatnot. But whenever we did that within whatever your favorite BI tool is, people that came through Excel or through something else or through another BI tool that didn't have that metadata, they didn't have the calculations. So what did they do? They reinvented them. And most of the time, incorrectly, right? So data becomes wrong. Even though you look at the same data, now you have problems telling different stories because your KPIs don't match up. So really important for us to split out KPIs and have a calculation layer where we do that. Then on top of that, it's basically just aggregations. Now it is by product, by customer, by segment, by location, by business line, by whatever. It's the same data that now rolls up to different use cases, right? But it's the same data based on the same calculations. And on top of that, that fourth layer here is the presentation layer. This is where we realized in many cases we need to present data in different forms. Certain applications or data miners prefer to get one very wide table, one key, hundreds of variables. Other applications wanted to have snowflake models. Other applications normalized data model. That then is just a presentation form of whatever works best for that environment. And all the way on top, we put that data lab layer, which allows us to basically give self-service access to little prototypes that people can build with all the underlying data. And if you look at how that layered data architecture is set up, and if you look across the board, here's some examples of how various different types of users are mapped against that logical layered data architecture. And you see that individuals like data scientists or the most advanced engineers that you have, they will see all the layers of the layered data architecture. They can drill down all the way to raw data. Very powerful, right? That also means that if they are part of a Scrum team that needs to bring in new data, the very moment data lands in that layer 0 of the layered data architecture, they can immediately start working on that, right? They don't need to wait for a data model to happen or for a dashboard to be written or ETL code to be written. They can immediately look at that data. Very important. Having said that, as powerful as raw data is to people that really know what they're doing, as dangerous it is for people that don't know what the raw data means, right? And so you see on the other spectrum, a regular user should never go anywhere near that because it is not governed, it is not pre-calculated, it doesn't have the calculations in it. And so you see different user groups will access different layers in that layered data architecture. Very important. The bottom, the further down you go with the layered data architecture, the more atomic data is. An event is an event, a transaction is a transaction, a reading is a reading. The higher up you go, the more you roll up data to see trends and patterns and KPIs and whatnot, right? I'm going to refer to that layered data architecture a couple of times throughout this maturity model because it's really important of how you apply it at the various different steps. So this was the first level in that maturity model. We call it the Agile Data Warehouse. Again, this is meant to help an organization become agile with data. Whether it is small data or big data, that is irrelevant. You need to be good at being agile with data, and for that you need self-service, you need things like sandboxes, you need governance that is automatic and built in, that you simply cannot avoid, and you need to do things like analytics about analytics that tells you who is doing what with data so that you can learn from that. Now let's go to the second step in the Sentient Enterprise, and we call it the behavioral data platform. And that's a really interesting area by itself because it represents a shift in mindset in a company. This, again, yes, there's technology involved here, but it's also a huge shift how a company deals with data and with customer data or with sensor data and how it is different from where we all come from. We all come from a transactional data centric view. We count how many products have we sold on Monday and how many last Monday and last month and last year, and we compare them and say, oh, we sold 5% more data this year, great. Well, or we sold 5% less, not so good. Why? Right? And the moment you start really asking the why, you start realizing that, yeah, transactional analytics is kind of bean counting. It tells me after the fact how much I have. It is not until you make a shift to behavioral analytics when you really start asking very, very different questions. And behavioral analytics not just looks at individual transactions, it looks at all the data points in between those transactions. And you start formulating behaviors, not just transactions. And again, you need technology to do that, of course, there's more data. But what you're doing is you're looking at patterns in between these data points. That's a different mindset. That's not necessarily what a BI developer looks for when they build a dashboard. They don't look for a pattern. They look for a roll-up, for a group by, for a calculation, right? This is looking in between data points and really stitching them together to behaviors. And, yep, it's 10 to 100 times more data because all of a sudden it's not just about a transaction, it's about the phone calls. It's about the feedback left. It's about a million things that you can do that we could capture if we had the data, right? And so as we're doing that, we're starting to look at the flow over time of what customers or systems are doing, right? As much as this is a customer-centric or human being-centric example, the same applies to machines. A machine, a gas turbine, an airplane engine, they have very specific, unique behaviors depending on what climate they're operated in, how old they are, what they're doing. Similar things. Same concepts apply to machines as they do to human beings. But by looking at behaviors, you now start stitching together, that person came to visit our store or our website. ultimately purchased something, called us in a call center, got something resolved, came back and purchased another thing, right? Or left us at some point in time because we did something wrong, or we were no longer competitive. And when you start thinking about behaviors, that's a big shift. That's a big shift in the mindset of not just the developers and the business analysts in the company. That's also a big shift for executives, because you not start thinking not so much about, oh, I have a new product on Monday morning. Who are the 5 million customers I can email to say, I have this product, do you want this? It is much more looking at behaviors over time and understanding where are my customers and where can I be most helpful or help them right now in their unique situation. So you start looking at individual machines and individual customers, not at the roll-up of the entire population. And as we're doing that, we're starting formulating behaviors throughout the company. When that happened at a place like eBay, we started building an experimentation platform. Why experimentation platform? Well, if you build, your product is a web page, right? You need to design new features all the time. You have ideas of what new features should actually attract new customers, right? And up until this time when we started doing behavioral analytics, it was the gut feel of some good designers or some good technologists to say, you know what, I think we should build this. And then we built it, right? And then we spent couple of months, maybe even years on it, depending on the scope of what the features were that we built. And then some of them were very successful. More often than not, they were not. And we started realizing, well, these gut decisions are really not what should drive us. And so we built an experimentation platform where we took new ideas, we built prototypes, we took a subset of the customers, of the traffic that hits the website, and expose them to different experiences. And we started doing A/B testing, multivariant testing, right? So if we want a new button on the site, should it be red, yellow, or green? Should it be left? Should it be right? Where do you want it placed? We tried all of them, and we would measure how people react to that. And now you start understanding individual behaviors, and the company starts thinking more and more around behaviors rather than transactions. It's a big step forward. And in part, the first step that we said before, this whole concept of agility and virtual sandboxes, is a playground, a starting point for an organization to think more and more about behaviors. Because now you can bring in behavioral experts, give them access to the data, let them structure it in different ways, build their prototypes, their virtual data marts, their sandboxes, and ultimately figure out which behaviors are important, which ones are good, which ones are bad, which ones we should encourage, which ones we need to avoid, right? And so it changes how a company thinks about data, and however, creates a lot more data usually, and all of a sudden, like, clickstream becomes interesting, and social media comments on Twitter, right? We need to know if somebody complains out in the public, because everybody sees that now, right? This is now public information, and so we need to combine more and more data, and we need to build platforms that can take transactional data and marry it up with semi-structured or fluid structured data, even unstructured data, right? To bring this together. And the layered data architecture, again, plays a key role in this, because, as I said before, with the different layers in that, one thing that we learned when we started thinking behavioral about our data is that integration layer has to evolve and change. As I said before, a huge data model is not the solution for this, right? It's a spectrum from highly modeled things to less and less modeled things. We came up with this concept that we called semi-structured modeling, where we even said we want structure and semi-structure or fluidity within a data model. We want a customer table or a transaction table that has 10 columns of things that we know very well, but it should also be able to have name-value pairs, XML, JSON data right in the same table, right in the same structure, so that we can do new things with that data without ever having to worry of data modeling it before. And it's totally okay to have repeating groups in there, and to not be optimized and not be third normal form and whatever your strategies are. It's really important to be able to quickly get that new data in there, deal with changing data very easily, and enrich a data model through that. But it's also very important to get back to that analytics about analytics step, where you now start analyzing what are people doing with that data. if there's new name value pairs or JSON elements that all of a sudden people are querying over and over, that is now a hint for you to say, oh, okay, this is really important or really interesting data now. More people are using this. That should now trigger a data modeling exercise. Let's take these 5 new elements that we have in JSON that everybody's now going after. Let's bring them into a data model. And so now you start thinking about data modeling as an evolution over time that you do even after the fact. You build the most minimalistic, minimal viable product data model first, keep semi-structured data there, but as you learn how people are using that, you shred out these pieces and stick it into a data model and make it better and more efficient and reproducible and governed and all these things that you need to do. So very important to have that capability of what we call semi-structured modeling, where you go from a spectrum from highly modeled things all the way to less and less structure. Name value pairs, clickstream that have just 60,000 name value pair combinations in that table, and you query through SQL in real time. That was the second stage of the Sentient Enterprise. This is where a company shifts from transactional analytics to behavioral analytics, where you start looking in between the transactions or why somebody bought certain things multiple times in the last 12 months, right? And it's a very different approach. It takes different thinking, it takes different strategies, it creates a lot more data that you need to deal with. You need to have new capabilities like semi-structured data modeling to deal with that, right? At the same point in time, you cannot give up on governance. You cannot throw away transactional data, because ultimately, every one of these experiments that I said we would do in the experimentation platform was measured by, did it drive more revenue? Did it create more profit? Or did it create more customer satisfaction, right? Not everything has to be a measurement of money. Especially for long-term thinking companies, they will invest into long-term happy customers because sometimes that's the most important goal, right? But it's important that whatever the metric is, you don't forget about them, and you don't make them up for redefinition every day just because you have not governed them, right? So very important to bring transactional and behavioral data together, but also hire new types of thinkers that now are much more algorithmic thinking people, much more the data scientist type of individuals that don't do just roll-ups of transactions, but look for the patterns in between that. With that, we're going to go to the third stage of the Sentient Enterprise, and we call it the Collaborative Ideation Platform. Big name. I'm going to tell you what that is. As we come out of that environment that we have built with these virtual data marts or data labs, right, where we have enabled more and more user groups within a company to build ideas they have just in time and try something out, right? The more we did that, the more behaviors we kind of instantiated or built within the organization. And more we had people that had to deal with all of that data, right? Not just the transactional data, not just the semi-structured data, but all of a sudden also all of these behaviors that are kind of grouped transactions and grouped things in between transactions. And we started realizing it's getting harder and harder with that much data to, for example, onboard a new employee. Get a new data scientist in here and say, oh, here's all of our data. Well, that's 100,000 tables. That's hundreds of thousands of elements. And oh, just this one table has 60,000 name value pairs in it. How can you possibly train somebody on an ever-exploding universe of data, right? And we started realizing that traditional concepts like metadata don't work. I can't have 5 people write metadata. And it was already difficult before when we had just our own company in the enterprise data model. Now with social data, with weather data, with external data, should we now model the entire world? Oops, this gets really difficult and complicated, right? And so we started realizing we need a very different approach. This cannot be centralized. We're going to create metadata and we bring that in and therefore people can use our data. We need to leverage everybody in the organization to help us do this job. And this is where concepts like crowdsourcing and social interaction with data are really important that you need to start to understand. At eBay, we built ourselves a platform that we called the Data Hub. And the Data Hub, by the way, it's not a system that processes data or stores data. It's a website. Think of it of what LinkedIn does for jobs, job networks or job search, what GitHub does for developers around version control and interacting with each other. The Data Hub was putting the data front and center and letting people interact with that. We created concepts like, I want to follow a data set or a visualization or an analyst. I want to like certain elements of data because I understand them, right? And all of these interactions, in addition to what we said before, data labs, analytics, follow along, what queries, what things are being done by people, when you overlay it with this kind of behaviors, what people are doing, who they are following, all of a sudden you allow an entire organization to participate in the creation of structure and tagging and metadata. Not everything is a gold standard. Again, it's a spectrum, right? Certain people are trusted more with their opinions than other people, especially a new grad is probably a less trusted source of information than a many-year-long analyst that knows the data inside out. But you need to bring them together. You need to make it very simple for them to find each other. One of the first things that we built was we built a Q&A forum section on that site, and I asked our support team and said, you know, for all the support requests that you get in through the data hotline, for everything that is not private or confidential, I want you to put it into the Q&A section of the website. Post the question, post the answer. And we're going to start indexing all of that with a search, right? Big part of that is you need to be able to find things. Metadata was indexed, just as comments were indexed, just as articles, Q&As, everything. We went into the metadata of tools like Tableau and MicroStrategy and indexed them as well. We even went so far, we hacked the toolbars of some of our BI tools and put a Data Hub logo on it to say, oh, if you find that thing, that visualization, you are really interested, all you need to do is hit that toolbar button. And from that moment on, you would have an embedded version of that visualization in your homepage on the Data Hub, right? You would be able to collect data elements as you see them in the organization. And by collecting them, you would tell us that you're interested in some way, right? So we could use that in the relevance of our search results to really now amplify what people are doing. And we brought people together that were working on similar problems within an organization that had no idea that they were working on the same problem. Most companies have that problem, that there is, at any given point in time, there's 2 or more departments working on a similar problem without even knowing that they're doing that. If they would, they could at least meet together and say, you know what, we're going to focus on this side of the problem, you guys focus on this side, together we are more successful, we are faster, we learn more about what that is. We ultimately built in concepts like crowdsourcing into that, and if you think about that, what we basically did is we allowed collaboration at an enterprise scale through concepts of sharing and liking and searching, and really making it the one-stop shop for everybody that needed to know something. If you went into your browser and you typed in data or Data Hub, it would take you to your personal page. You would find in there with search as much as we know about data that exists. We would index every wiki in the company in this thing, and we would correlate it with KPIs and metrics and data models, and all brought that together in one place. There's tools, obviously, in the industry that do that, right? There's various companies that use crowdsourcing for very interesting things. One of the companies that I want to point out is AGILE, for example, right? It's a data scientist competition crowdsourced company. If you have a scientific problem or an algorithmic problem, and you're willing to give an anonymous data set, a training set, and a result set to them, you will, and you set out some sort of prize money, right? You will get data scientists from around the world to start competing. Who has the better algorithm for your data? Very interesting concept if you think about it. It's ultimately modeled after a Netflix prize that Netflix did in 2009, where they basically put up $1 million to say, for those that build us a better algorithm on how to predict what we should recommend you as your next movie, it's worth $1 million to us, right? And if you think that through, that is a really powerful story because it engages people with data in new ways. And we need to bring that kind of concept into our organizations. Some of our companies have tens of thousands of people that all deal with aspects of data in one way or another, but they're completely separated from each other. They don't talk to each other. If you don't sit in the same group, you probably don't even know that somebody else exists that has a similar problem. And so bringing these concepts into an organization, very important. And again, the layered data architecture plays a big role in there. These data labs and what people are doing, and I talked before about analytics, it is crucial that as the service provider of an analytical platform, you know what people are doing with analytics. Because only when you start building these kinds of analytical models, you can use this now on a website like the Data Hub to say, hey, you know, here's a result that I should push up higher in search. Or maybe I should start merchandising data. When you come to your Data Hub homepage, maybe I should point out some data sets that people that work on similar problems like you are also using, but you have never used them, right? Or point out people that have done similar work as you have so that you connect them into groups and communities within the company, right? Really important. Analytics about analytics. Ultimately, at eBay, we hired a data scientist whose job it was to find patterns and KPIs about the usage of these systems. And for anybody who does analytics at scale with a lot of self-service in mind, with a lot of agility in mind, with a lot of behavioral analytics in mind, this analytical aspect is a really important one for an organization to think about, to size for, to hire people for, and to do something with that data. So that was the third stage of the Sentient Enterprise, and it's basically how to enable collaboration at scale within an organization. It's about thinking about this LinkedIn for analytics. What is your internal hub that you can go to and you find out everything there is to know about analytics, where you find all the self-service tools, whether it is data labs, whether it's data load utilities, whether it tells you how much you have used out of the analytical infrastructure, all the self-service tools need to be there. And it's really about crowdsourcing metadata rather than trying to run massive metadata projects that then are outdated at the very moment they're turned live, right? So, great. So now we have built data labs. We have enabled agility within a company. That has led to a lot of behavioral analytics within a company that has created now so much more data and so much more interaction. Then we built a collaboration platform that allows people to follow each other and learn about data that is out there. Great. So now we are producing more and more analytical output in a company. More and more insights are being found. But if these insights turn into an email to tell somebody, I found this, and this email gets ignored, doesn't get implemented, all of a sudden you start realizing that you're building a lot of output that the company is no longer able to act on. We're not doing anything. Sharing that idea of what I just found with somebody else, if that has to go through screenshots and email, even through a collaboration platform, if it stops there, the best insights are not worth anything if you can't act on them. A company needs to be enabled to implement them and do them over and over and over. And this is really where the analytical application platform comes into play here. You need to allow people to do what we have done with the app economy on various other platforms, right? Because today how organizations operate is very much centralized development teams that have to code something. We need to go to a place where platforms like mobile devices, like other web sites, have built themselves so that other people can build on top of their platforms, right? And this is not a way IT typically thinks about their products. When we think about applications in IT, we think about ERP, we think about CRM, we think about multi-million-dollar software packages that take 2, 3, 4 years to implement, right? What I'm talking here is mini apps that are as small as the things that you run on your cell phone that somebody like a college grad can write without having to be the expert of all the underlying platforms, right? Really important to turn an analytical ecosystem into a platform that other people can iterate on it. And if you want to do that, you need to get to concepts like zero-cost deployment. You need to learn from cloud and from DevOps what does it take to write a new application and push it. And what does it mean to push it 5 times in a day? How do I keep version track of that thing? How do I measure if these apps work? How do I measure if they consume a lot, right? All of that, if you take that into a self-service environment, you need these analytical capabilities, but you need to enable different teams, not just to have a data lab, but also build an app on top of that by themselves, without having to go and ask somebody for permission or get in line to get resources. The one example that we've done at one of the companies that I've worked at is we realized we need this kind of a platform. And we built ourselves the most primitive, simple application platform that allowed us to take workflows and concepts, things we found in data and that we agreed, oh yeah, this is a great insight, and then codify it into an application. And that example that I have here for you is, so we started realizing that we needed to build customer segmentation at a very different level than we had done before. It is about the fact that most companies in the world that you walk into, when you talk about their customer segments, they have usually a handful of them operationalized. And when I talk about operationalizing that, it means where when you go into different departments and you tell them what customer segment you're looking for, that they would pull up the exact same definition with the exact same number of customers in it, and they would use the exact same metrics to describe that. And so we started realizing we don't have that, we need to build something. We had 7, 10 customer segments defined very well. We said, okay, let's do this in an app world. Let's build an app that can do thousands of segments, millions of segments. And first was like, that's stupid. You would never do millions of segments. And we're like, well, maybe not to begin with, but maybe we do. And more importantly, if you go to a development team that has built dashboards for 7 customer segments and you say, well, build me 14 or 20, the first response that you will get is like, well, can I get more headcount? Right? I need to do more scripts like I've done before. It's like, we need to think very differently here. We need to build something that can do 1 million segments. Well, obviously, that can't be ETL scripts that we copy around, right? It needs to be an app. We built an app in 6 weeks where we took 50 segments that we just wrote down from various interactions with business executives, and we rolled that out. In 90 days, we had 1,000 customer segments defined. And because we built this as an app, we rolled new versions of that every day when we needed to. And the segment definition just became an input on a web page ultimately, right? To say, I want this segment, right? Or do we have a segment that we have already? Very different if you do this in traditional ETL or if you do this in an app economy, where it becomes an app that you can deploy and you can iterate on it, and where you can have a very small team of 2 or 3 engineers build new applications. Very important for an enterprise to make that step from centralized ETL coding and centralized massive scale applications to enabling smaller and smaller apps that take insight and make it reproducible for others in the company to consume, or to even drive email campaigns, changes on a website, changes to pricing, or various areas that you have, right? Really important. The other part of the app platform is something that a lot of companies are constantly dealing with. There's a lot of people within organizations that ask for new data. And they usually outnumber the number of people that can actually do these ETL jobs by more than 10 to 1. And so everybody has to get in line for new data to be loaded. And the way we go about it with traditional ETL schemas is go find an ETL tool, go find wherever the data sits. Now let's start drilling holes into that system and pull the data out. And first of all, the owners of that systems sometimes aren't too thrilled about it, because taking a day or a month or a week worth of data out of a source system can be pretty taxing and expensive to that system. And it takes a lot of time, and it's very non-agile. It usually takes months for new data to arrive, right? And so a couple of years ago, we started realizing the concept of data integration through ETL, the way we do it, has its place, but there needs to be something that is way broader in definition than that. We need the ETL part, we need the T part, and we talked about the layer data architecture. I'll get back to that. We need transformations, we need KPIs, we need metrics, but how data arrives needs to change dramatically. And we came up with that concept of a data listening platform, where we said, rather than sending people after the fact to systems to pull out the data, how about we build a platform that listens to incoming data and that guarantees that all the data that it listens to will store it for you, will do something with it, right? What we do with it, okay, there's use cases to be built that. The first step is to enable enterprise listening. And it was interesting, the first time I gave that presentation, I had some executives from Disney in the audience, and after the fact, I talked to them, and they said, interesting, we just built ourselves a listening platform. And the reason we had to do that is because we just rolled out a really magnificent new capability at Disney World. It's called the Magic Band, right? So if those of you that have stayed at Disney World or have taken your kids there, nowadays if you book a trip there, they send you a nice little box a week or two before you do your trip in the color of your choice with the Disney icons of your choice, and it's your bracelet that you wear around the park. It lets you check into the hotel, it lets you open your hotel room, it lets you get into any park, it lets you buy concessions at every stand that you want, and oh, by the way, if your kids wander off and you lose them out of sight, they can help you find your kids, right? And they started realizing that capability, very powerful, by the way, coupled with things like FastPath. You can go in the night before, plan your entire day in the park from a website, and they guarantee you that you will not wait in line on any of the rides all day long for more than a couple of minutes. That's all empowered by something like that, right? And they started realizing the number of touch points that these bands will have to talk to. If they do traditional ETL, they would be for years writing ETL scripts, and the data would come out of every system in a different form. And they started realizing we need to turn this upside down. We're going to build a listening service, and we make it very easy for every application out there to drop their data into our listener, right? Here's that one-liner that allows you, with your authorization, to drop data in here. And so all of a sudden, data integration becomes not an after-the-fact ETL job, it becomes an active as you develop new applications. You can listen to data from mobile platforms, from applications, from servers, from external web pages, from internal data sets, if you build a platform like that with the proper capabilities. Again, the layered data architecture plays a key role here, because that listening infrastructure, for example, how do you do real-time listening? Well, you want to deposit data into layer 0 of your layered data architecture. As we said, layer 0 is no ETL, right? Give me data in what structure, persist it there. Perfect for listening, because we're going to listen to JSON data structures, XML, name value pair, or others, and we keep that structure and we put it into layer 0, right? Instead of building ETL scripts with app, we now build data engines. We build applications that take input data and create another level of data. So as we move data through the layers of the layered data architecture, we build more and more of these data engines as apps that can live by themselves to deploy them as we need them in an organization, and ultimately allow people to do mashups in their data labs where they combine existing applications or existing outputs and do entire new workflows, visualizations, outputs for email or campaign systems, or inputs for pricing models, right? The app economy applied to an IT infrastructure is a very, very powerful concept to allow more and more people to participate in building small little apps that allow you to automate processes and learnings from data, rather than always having to go back to an IT department and say, okay, here's a requirements document, here's several months of wait time, and then we build something, and then, oh, it's not exactly what you asked us for to do, right? So, again, layer 4 of the Sentient Enterprise is really centered around platform enabling your infrastructure. It's turning yourself into an app-enabled platform where apps can be deployed just in time with DevOps, with cloud in mind, and not the traditional ETL. Once a month we roll out ETL code, and because we only do it once a month, we never get really good at it. For the longest time, at one of the companies that I worked for, we would roll out new ETL changes every last Thursday of the month, and then every last Friday of the month we cleaned up all the things we broke on the last Thursday of the month, right? Because we did it only once a month. That means most development teams would only participate a few times a year at best in this, because they wouldn't have something to roll out every time. And so you don't get good at that. And we would have to tell too many people what to do. It's the idea of the app economy to do just-in-time deployment. And if you enable that with cloud capabilities, with DevOps in mind, you can move so much faster. Again, it's ultimately agility and creating output and letting more people participate within an organization to create these analytical insights and actions and output. So that takes us to the fifth step in the Sentient Enterprise and the maturity model, and we call it the autonomous decisioning platform. And this is a really interesting step where you start applying new ways of dealing with data and new types of algorithms at scale like you have never done before. This is not about a churn model that predicts how a particular customer might or might not churn. It's not a dynamic pricing model that decides how you should price your products. These are models that we're going to talk about here that look at all of your data, all of your KPIs, all of the trends, everything, and that help you decide where should human beings look at. Because the big problem that you have as we have built all of that is like, so we built virtual data marts, great, lots of sandboxes out there. We went from transactional to behavioral analytics. Okay, even more data, even more insight, right? Okay, we connected everybody with social and crowdsourcing and made everybody smarter to produce even more output. Now we build apps that implement a lot of things and even more output happens. And ultimately you arrive at a stage where you might have hundreds of analysts within a company and they start their day pretty much not knowing what they will do today. So by now you have hundreds of dashboards, visualizations. So which ones are you going to look at today, right? The ones in Germany, the ones in Sweden, the US, East Coast, West Coast? Where will I find a new needle in the haystack? You don't know, right? And so more and more of the people time is spent on sifting through data and not knowing what to do. This is where the autonomous decisioning platform comes in. Today, we spend upwards of 90% of our people time in just digging through mountains of data, KPIs, dashboards. There's more dashboards in the world today that have millions of drill down options in a single dashboard than one wants to believe. Because by the time you have all these dimensions and you drill down by geography, by product, by customer segment, oh, now we have 1,000 customer segments. Which ones do you drill down as an analyst to look into, right? All of them at the same time? You won't be able to do that. We need to change that. We need to change how we spend time on searching for these needles in a haystack and how we turn this into, we want to spend the majority of our time in making decisions, because this is where we as human beings are really good at, right? And we should do that. So there's a couple of concepts here that are not necessarily new to how we deal with technology. One of the up-and-coming technologies that you might see around is like the whole concept of self-driving vehicles. How is that possible? Well, the decision maker is the human being, right? Where do I want to go? But it can do certain things with algorithms very good. Even if you don't happen to have a self-driving car just yet. More and more cars have things like adaptive cruise control. What makes adaptive cruise control really interesting is the computer on board of the car can check 60 times a second the distance to the vehicles in front of you. Way better than you can ever do, right? And by the way, it will not get distracted by that police vehicle sitting on the side of the road, right? Or that other thing happening over there. And so there are certain things where algorithms and systems are really good at, right? And when you apply that to data, that becomes really interesting, because looking for outliers is what systems and algorithms can be really good at. Now, you need to avoid the false positives. You don't want to make a right turn where there's no street, right? You don't want to hit the brakes if there's nothing in front of you. You have to brake. Another example of that is the whole concept of automated trading. Today, in the world of finance, the vast majority of financial transactions are automated, right? They're driven by algorithms. And there's a lot of investment going into algorithms on how to do that. Why? Because you want your experts not to look for every stock transaction. You want your experts to train the models of how to interact with it and then apply it at the millions in milliseconds, right? So these are kinds of concepts that we as companies need to adopt to learn with data at scale. Because by the time we have hundreds or thousands of KPIs and we have all of these visualizations and all these dashboards and all these apps producing more and more and all these behaviors, where should we start, right? It needs to be something where we leverage algorithms to say, you know, today the top 3 outliers are these things. Somebody should look at that, right? Rather than sending hundreds of people to trying to find that. And we see companies nowadays that are starting to go down that path. How do they build that layer on top of their analytical infrastructure to basically compare every KPI with every dimension, with every drill down, with every customer segment to say, where are anomalies happening? And can I focus my human beings on these anomalies rather than sifting through data? So what we have now done is basically creating an organization as a single organism. We are putting things together where we let more people work closer together, where we let them share, identify new concepts, give them data labs, build collaboration, follow people, learn from other behaviors, build repeatable processes like apps to do something about that, and ultimately wrap algorithms around that help us make ourselves more productive by showing us where we should look next, right? And this is ultimately the end goal of the Sentient Enterprise, is like bringing all of these capabilities together. Now, the 5 levels that I've just told you, you will not find a company that has implemented all 5 of them. You will not be able to do that in a couple of months or even a year or even a few years. It will take for every step, sometimes multiple years, for an organization to get really good at that. If you want to get agile, it will take lots of learning, it will take a lot of transformation, and it will take time. If you want to do behavioral analytics, you have to bring in new types of thinkers, new types of analysts, data scientist type of individual that think about patterns instead of transactions, right? And as you go into every one of these levels, the more and more you implement of that, the more and more you bring an organization together as a single organism. And so that was the last level. This is the autonomous decisioning platform. Again, we said predictive algorithms that help you look at anomalies in data across the board, right? Really an important step, because it has the potential to shift where your teams are spending time on, from sifting through data to actual decision making in a company, right? And so we talked about all the various layers in here. Just to recap one more time very quickly, the Agile data warehouse, moving from a traditional centralized waterfall driven write a requirements document to a centralizing the data but decentralizing the use cases. Allow people to do data labs, but govern it, right? Create analytics around that. Know what people are doing. Don't let that turn into wild, wild west, where after a year you no longer know who built what. You need to have concepts like fast path methodologies in there. If somebody built a prototype, help them get it into production very quickly, right? Without these requirements documents. Behavioral data platform. This is really where you, as a company, make that shift from transactional analytics to behavioral analytics. And that goes all the way up to the CEO. This is all the way, it's a different mindset that a company is at, that thinks about behaviors of customers first before the product lineup, right, that you have, or the behaviors of machines and how you can optimize them and how you can learn from that. The third level, the collaboration platform, really now crowdsourcing, enabling an organization at scale to come together and collaborate with each other and realize that more experts together are much more powerful than each individual of them can be, right? A really important capability. The analytical application platform, now make it repeatable. Now all of these things that we have done in the first 3 steps, we now need to make that repeatable and wrap it into apps that we can deploy and write very, very quickly, and where even a college grad coming into the company can leverage that data and can build something, right? And finally, the autonomous decisioning platform. This is where algorithms and predictive work, not for one particular use case, but at scale in the company comes in, right? And And as we build this, we're turning a company that is highly ineffective in and problems like the left hand doesn't know what the right hand does, or problems like by the time I've told the same story 5 times over, it sounds so different, right? And we have these problems within organizations, and usually executives are very removed from the actual happening, from what is going on with my customers, with my products, because by the time data gets to them or stories or insights get to them, they sound so different from what they are. And they're usually outdated and old, right? It takes a long time to understand what implications are. And so the Sentient Enterprise is the concept of bringing these capabilities together. Think about data, listen to data, learn from data. You know, these are concepts of a sentient being, and if you think about it, every human being is sentient by definition. We know that we exist. We listen to things, we learn. We learn particularly good when we are 4 years old and we get a bloody nose on everything that we don't do well. It's these kinds of capabilities that we need to bring to organizations, where we bring more and more people together, but bring them together not in the way we do today, but through data, through real-time interaction, through self-service, through listening, and really transform an entire company, ultimately for agility and faster than agile, as we sometimes hear. And ultimately the end goal is that Sentient Enterprise. It's a goal that is as impossible to achieve as Six Sigma is in quality, or as zero inventory is in supply chain, but it gives you that goal that you can model yourself after, that you can build yourself a roadmap and say, what do I need to do to get closer and closer to this perfect goal, and how do I structure myself? What people do I need to hire? What are the concepts that I need to implement over the next several years in my organization? And with that, I'm gonna close out this presentation. Thank you very much for joining me today. This is the Sentient Enterprise, and I wish you a great day.